Gera is a professor in sustainable soil management at the AERES University of Applied Sciences, and she has been working on sustainable soil management with a focus on the long-term soil ecosystem services. There's on the soil health, on soil quality, and today she will focus on the use of organic matter in her presentation. So for the next half an hour, we will listen to her.
Well, thank you for inviting me. And indeed, I will focus on soil carbon and the functional agrobiodiversity in soils, of course. In my presentation, I will tell you something about the necessity for a change, and that's because the world is changing, the world around us. I will tell something about the soil organisms which support us, our cultivation, our food production. And I will highlight how we can support the soil organisms in return, obviously also for our own benefit. And I will end with some slides about organic matter management. Well, about the necessity. The world around us is changing, and I'm not telling you anything new because the most obvious change is, for example, the climate change. In the future, we will have to cope more frequently with extreme rainfall, showers, and then we rely on the infiltration capacity of our soils. So that will get worse. So we will need better infiltration capacity and better water holding capacity than in the past. If we don't, the water will run off to the surface water, taking with it all kinds of fertilizers and crop protection compounds, and no one wants that because that will lead to even more restrictive regulations from the EU. So we have to attend to that. And within the climate change, we also have to deal with longer periods of extreme drought in the future, more than in the past. And therefore, we should rely on our soils for water delivery, water supply. And even in a wetland as the Netherlands, you can't rely on irrigation because in many cases it's being prohibited due to lack of fresh water. So without irrigation, you rely on your soil quality in the future more than in the past. And on top of that, actually, in the Netherlands, almost half of the acreage suffer from overcompacted subsoil due to the use of very efficient but also very heavy machinery, for example, for harvesting. And if you do that under wet conditions, then you get a compaction of the subsoil. And you can see here on this map, all the orange area acreage and the brown ones have 40 to 50% chance that they're overcompacted. And of course, that does not benefit the soil organisms. So we need to improve our soil quality. And in the Netherlands, we also have other problems and challenges, and it depends where you are with your farm in the Netherlands, whether you are also challenged by soil subsidence with different causes or challenges with soil salinization. So it depends where you are on your location, which challenges you need to cope with. Anyhow, anywhere in the Netherlands, there's time for transition. Where in the past we were focused on yield maximization, we have to go to a more integral approach. We still need to focus on food production, of course, to feed the growing world population, but we also need to focus more on other soil ecosystem services like carbon mitigation, water management, and biodiversity. And this all had to fit in a new concept of circular economy. Well, it's quite a challenge. It's not just the Netherlands that's coping with that. Worldwide, people are talking about these global issues, and people are really agree on that part of the solution for these issues, we will have to look underground for that, because part of the solution can come from factors like soil organic matter contents and soil biodiversity. And that indeed is the focus of my presentation of today. If we look at soil and soil organisms or biodiversity, well, earthworms are by far the best known soil improvers, and everyone loves earthworms because they make their burrows, and as a result there's better aeration, rooting and water infiltration capacity of the soil. They take care of bioturbation, mixing organic matter through soil, and they add to formation of soil aggregates because they're quite slimy and they produce slimy excrements. Well, so people are very happy with earthworms and well aware that they are important. Actually, earthworms are very good for crop growth and yield. If you take all literature into account worldwide, where scientists investigate compared cultivation with and without earthworms, then earthworm activity results in more or less than 26% yield increase. So that's quite a lot. But what many people do not realize is that earthworm activity is actually also bad for us, because activity of earthworms stimulates the emissions of carbon dioxide and nitrous oxide. And especially the last one, the laughing gas, is really stimulated by earthworm activity. And this gas is 300 times worse in warming effect on global warming. So this is really something to take into account. So this is my way to say we love earthworms, but not always. And if you intend to increase your organic matter inputs, then you will also stimulate earthworm activity and therefore also these gas emissions, the greenhouse gas emissions, which is unwanted. Well, if you look at a picture of the soil food web, and there are many pictures of it, and I expect Koen will have a different picture, but I mean to say that this is a complex food web of all kinds of types of organisms in the soil, and earthworms are just here in the corner, only one of them. The biggest role, the most important groups in the soil food web are not the visible organisms, but in fact the microorganisms that we can't see, because the groups of the fungi, the bacteria, the protozoa, those are the ones producing enzymes to decompose organic matter. So the microorganisms are far more important actually than just the earthworms that we can see. Most species in the ground, in the soil, we actually do not know. There are so many. About 10% of those organisms we can see or almost see with the naked eye. And the majority, the vast majority of all species are microorganisms, mainly bacteria and fungi, and they represent about 90% of all soil biodiversity. So that's almost all of it is microscopically small. And if you look at the numbers and the biomass, that's quite impressive. And we also, as humans, we identified species, and for bacteria and fungi, that's tens of thousands of different species in soil. But scientists estimate that we know that those tens of thousands of species is only 1% of what is actually there. So the vast majority, 99%, we do not know. But we do have a clue of what they are doing in this soil. And these microorganisms influence the chemical, physical and biological quality of our agricultural soils. And I think I'm not telling you anything new here. The chemical soil quality influenced by microorganisms is all about the decomposition of organic matter, so the mineralisation. It's about nitrogen fixation, it's about nutrient uptake. The physical soil quality is influenced also by these microorganisms. They're very small and yet they play a very important role, for example, in aggregate formation and structure stability, because the fungi, they knit, they stick all these soil particles together, and the bacteria do so as well because they're quite slimy. Well, and biological soil quality, well, one very important aspect of that is disease suppression. And I will focus in on that some more. But on the whole, actually, these soil microorganisms, they are far the most important group within the soil food web. Focusing on disease suppression, we know there's some bad boys in the microorganisms in the soil. We call them pathogens. They parasitize on our plants, so we know them well. They bother us. But there's all kinds of useful organisms in the soil as well that suppress the pathogens. And the mechanisms that they use are a competition for space and food. It's production of antibiotics. It's probably predation and parasitism, and one eats the other. And a less well-known mechanism is involving volatile organic compounds. Some fungi produce volatile compounds, for example, methylbutane in this example. And you see here on this petri dish, which is separated in two compartments, that the fungus here on the left produces a volatile compound which suppresses the growth of a pathogen on the right. Here you have the pathogen on its own, which is growing on the agar plate, but on the right hand side you can see it's completely suppressed by the volatiles. That's a very nice mechanism in soil, since the volatiles can spread through the pores in the soil structure. And another mechanism for disease suppression is called induced resistance, where an interaction between useful, harmless microorganisms in the soil and interaction with the plant roots may trigger the plant to activate its defense mechanisms, and thereby preparing the plant for attack again by an actual pathogen, because then the plant will be more resistant. These are all different kinds of mechanisms for disease suppression, and every pathogen is susceptible to a different type of mechanism. And if you want a soil to be suppressive against diseases, you need actually every mechanism there is. You'd like all these examples to be in your soil, so it is suppressive to different diseases. Well, and in fact, plants are very much in control which microorganisms they attract to their root systems, and they use root exudates for that. So plant roots excrete all kinds of compounds, organic sugars, amino acids, nutrients for microorganisms, and the composition of the root exudates determines which microorganisms are attracted to the plant. And every plant has different concentrations of nutrients in their exudates, and by that every plant species attracts different microorganisms. And scientists have proven only in the last few years that if a plant suffers from stress, and that might be different stress factors like nutrition deficiency, drought, or an infection by a pathogen, these factors influence DNA that is being replicated. It influences then the compounds, the amino acids that are produced. It's kind of a chain reaction that in the end lead to a change in the composition of the root exudates. And if that's changed, then other microbial species are attracted from the soil, and it is proven that depending on the stress factor, the roots attract specifically helper organisms, microorganisms, to help the plant against this stress factor. And that's a very nice mechanism. But on the whole, it means that a farmer is benefiting from a high soil biodiversity, where all kinds of helper microorganisms are present. And a farmer has to make sure that the soil stock is in order. And if you talk with farmers about soil stock, most of them think about nutrients, but actually that's of secondary importance. The first main important thing to think about is the microflora, so the microorganisms, the stock of them. You need all the helper troops to be present at all times, because in the rotation you will grow different crops, and you want each of these crops to be able to attract the helper troops, the helper microorganisms that they need, depending on the stress factors that will occur during cultivation. So a high variety of species, that is a high biodiversity, will ensure a multitude of helpers for different situations. And that is why soil biodiversity is essential for a resilient crop cultivation and a resilient food production, which is resistant to different stress factors. Now, soil scientists are well aware that soil biodiversity is under threat. We don't know all the species, but we do know that the biodiversity is under threat. And this is a map from the European Atlas of Soil Biodiversity. And you can see in this map that indeed, anyway, the Netherlands are coloring dark red, being a high risk for decrease of biodiversity. And the important factors that are mentioned here are something with organic matter and soil compaction. Well, I showed you already also a map with soil compaction, so that is correct. And well, that's not so good, right? And but it doesn't come to me as a surprise, because in the past, the cultivation practices that we used are not very friendly for microorganisms in the soil. So I'm talking about frequent tillage, about the use of pesticides and mineral fertilizer, and of course, here again, the heavy machinery compacting the soil. Well, everyone knows this will not benefit soil biodiversity now. So if our soil biodiversity is under threat, then the resilience of our cultivation system is under threat. And so we need to be alert, because these soil organisms are responsible for very useful ecosystem services, as mentioned before. And we need those services very hard. So now I've clarified the soil microorganisms, so all soil organisms support us, support our food production. They are actually very essential for our food production. And how can we support them? Well, to start with is prevent soil compaction and apply reduced tillage, because if your soil structure is in order, once it is in order, every disturbance doesn't help the microorganisms. So this is what you do first. Be sure that your soil structure is in order. Then, of course, there's many ways a farmer can do that. Here are a few buttons to turn. As an example, there are even more. I will not go into detail on these practices to prevent or improve your soil structure, prevent soil compaction. Another thing we can do to support soil organisms is crop diversification and more cereals in the crop rotation. And we already know some examples of grass clover mixtures, that's diversification, green manure mixtures, and relatively new is the strip cultivation or pixel cultivation. It is being proved in science that mixed crops or strip cultivation will lead to more biodiversity and more biomass above ground as well as underground, more carbon and nitrogen in the soil, better rooting and water management, and fewer fungal diseases. But if you do use mixed crops, really pay attention to the host status, because you don't want to multiply plant parasitic nematodes. So crop diversification is positive, it stimulates soil biodiversity, soil biomass, and activity of the soil organisms. And this is a quite impressive graph with about 46 lines in here. This is a summary of worldwide publications on long-term field experiments. And all these experiments, 46 in number, they were testing the effect of crop diversity. On the horizontal axis, you see the biodiversity of crops cultivated. So that's the number of species in the crop mixture. And on the vertical axis, you see the resistance of the crops, the mixed crops, against stress factors. And the result, you see most of the lines go up. So the result is that the more species you have in your crop mixture, then despite all kinds of stress factors, there was less yield loss compared to monocultures. And also in the mixed cultures, there was a faster recovery after climate events. So after flooding of the fields, after desiccation of the fields, if you were cultivating a mixture, then there was a faster recovery. So also in crops diversification, crop mixes are positive for the resilience of your food production. Now, another thing, and a very, perhaps the most important aspect to pay attention to, if you want to support your soil organisms, you have to manage your organic matter in the right way. You have to add organic matter because the soil organisms need a good living condition, meaning a good soil structure, and that you can get with stable organic matter, which is not easily decomposed, but which is there for a long time, guaranteeing a good structure. And on top of that, the soil food web needs easy decomposable organic matter because that's their food. So you need both types of organic matter to help soil life. One is for structure and living conditions, and the other is as a food source. Now, knowing that, I've given this presentation many times, also, for example, for this group of flower bulb growers in the Netherlands. And they wondered, they said, well, it's not easy to increase your organic matter content in the soil. That will take a decade, whatever. But what can we do within our cultivation system with flower bulbs? And they thought of a field experiment by themselves. There were 10 farmers, and they said, let's compare. We all already use compost. What if we double the dose of the compost? Would that make a difference? Or with or without a green manure crop? Does that make a difference? I said, well, we'll see, we'll have to test. So they started a project on their own fields. And their main question was, if we change this, if we do these treatments, does that actually stimulate soil microorganisms and increase disease suppression? Because we have to do with less pesticides, so we want to increase disease suppression. And does this organic matter management treatments, does that help? Well, this was, for example, their trial plots. Each of these flower bulb growers had a plot like this on his own farm. And they all had a strip like this with a single dose of the compost. And next to that, they had a strip with a double dosage of this compost. They all used different kinds of compost, that didn't matter, but they had a single and a double doses next to one another. And across that, there was a strip without green manure crops. Between cash crops, they had a strip with fodder radish and a strip with Bristol oat. And the cash crops were all different with these 10 farmers, but these treatments of green manure crops were identical. And they did this for 3 years. And after 3 years, I took soil samples from these plots and tested them for disease suppression. And this was one of the results. This is a result, a graph of a bioassay for disease suppression against the root lesion nematode, Pratylenchus. And what you can see here on horizontal axis is the green manure treatment. On the vertical axis, it's the percentage of root rot caused by the nematode in the test crop narcissus after artificial infestation. The blue bars are the single dose, the red bars are the double dose of compost. And what you see is that the red bars are always lower than the blue bars. So double dosage of compost results in less root rot. Also very easily to be seen is that the green manure crops also give less damage caused by the nematodes. And the best treatment of all is a combination of the double dose compost with the green manure crop. Well, the growers were very happy with this result. So more organic matter, less root rot. And now they said, now we believe the story that you just told. You need a combination of relatively stable organic matter, being the compost, combined with easy degradable organic matter, being the green manure crops. And the combination of both give the best result, in this case, for disease suppression. So that was a very nice experiment, and actually these growers said, soil life is just like, they are just like people, these microorganisms. Well, for people, we use this wheel of 5 for food, and healthy food is varied food, and these growers said, okay, so we need the stable organic matter combined with the label organic matter, and in practice, that means that you have to use the organic inputs that are available, and you need to vary them, alternate them, combine them just as is practical within your crop rotation. So use what's there, and you have to figure it out for your own crop rotation, for your own cultivation system, which combinations are practical. So that's the main message about the organic matter management and which ones to choose. So organic matter is actually like black gold for our soils. And again, I think I don't tell you anything new. There are a number of practical methods to increase soil organic matter. I'm not going to talk about them individually. So you can apply, you have different inputs. You can apply organic matter, and also you can reduce the decomposition of organic matter by reducing soil tillage. Now then there's the question, to what percentage do you have to increase your organic matter content in the soil? Well, there's no right answer, because there is no ideal soil organic matter content, because that depends on soil type. And here you can see in this map in the Netherlands, it depends on where you are, on the location, what an average organic matter content is. And it's most of all important to stay in balance, so that at least you compensate for the average decomposition of 2% per year. And there are very nice online tools that you can use for your own calculation of the carbon balance, organic matter balance. And you can choose the one that's most friendly for you to use. If you can try them yourselves. They're for free. So now I have an example to think about interactions between accumulation and mineralisation or decomposition of soil organic matter. This graph is a calculated prognosis, and it compares two extreme organic matter management strategies. The one is only the use of compost every year, and the second is using only liquid pig manure every year. And this is a long-term calculation, about 50 years. What you see here, it's about the accumulation of the organic matter. If you use the pig manure, there's no accumulation, because all organic matter that is present in the liquid pig manure is very easily degradable, so you don't accumulate anything. While using compost, you can see there's a gradual increase in organic matter content in the soil. And of course, with all positive side effects of a higher organic matter level. Now, if you compare with calculations for nitrogen mineralization, so the availability of nitrogen for crop growth, you can see with pig manure, you have instant high availability of nitrogen from the manure. If you compare that with the compost, then in the beginning, there's only slow mineralization, so there's not enough nitrogen for a good yield. But in time, somewhere between 10 and 20 years, there's so much organic matter accumulated, which is breaking down with 2% per year, then you have a high enough level that even with only compost application, you will have enough nitrogen availability for a good crop growth, and it will even go better. Now, in the long term, you will be better off with compost because you will have enough sufficient mineralization combined with a higher organic matter content, accumulation in the soil, with all the benefits. So this is actually the basics on which you can choose which organic inputs you'd like to use. And of course, it's down to combining and alternating them. And if you have to qualify organic inputs relating to their addition to soil quality, then the liquid manures have a minor value. The crop residues and solid manure are reasonable to good for soil quality, and composts are very good. And of course, you have to take into account all EU restrictions for the application of phosphorus and nitrogen. And in the Netherlands, for composts, only part of that, of those 50 or 10% are taken into account. So you can play with that a little. You can use double amount of compost based on phosphorus content if you compare that to manure. And based on long-term field experiments from Wageningen University, scientists estimated the financial returns based on the soil organic matter content. And they calculated that per kilogram organic matter in soil, you earn about 40 cents, euro cents per kilogram organic matter in soil. Now, and if you use these organic inputs, you can calculate backwards what the value of these inputs can be for your cultivation system. And these are the price tags, so calculated back from this value. And you can see that the liquid manure, pig manure, is for free in the Netherlands. It doesn't yield much, doesn't add much value to your soil and your yield. But if you compare that then to the solid manure, that renders you in the end 50 euros per ton. And using compost will give you in yield in euros 75 euros per ton. And then it's strange that farmers are reluctant, some farmers are reluctant to buy compost because, ooh, that will cost 8 euros per ton. But they never make the calculation how much they will earn using that compost. So this is only indicative, so it's indications of price, just to learn how to think about this in a different way. Well, all in all, I think because challenges are very location specific, tailor-made advice is key. And you have to focus on integral and long-term approach on soil organic matter management. And only recently, 1 month ago, this report was published. And it gives a very nice differentiated advice for combinations of various organic and mineral fertilizers per soil type and per phosphorus status and per crop. So in this report, there are nice examples of how to calculate which combination of organic inputs could be advised. And it's all also about timing, the timing of the application of your organic inputs, because the timing influences the time when the nutrients are available and can be taken up. And it's also important for the leaching and other emissions. So that will always be tailor-made, location-specific, soil type-specific, and crop-specific. So there's no golden advice for all of you. You have to work, you have to make the puzzle together with, farmers have to make the puzzle together with their advisors. And of course, there will be dilemmas, of course, and mainly about money and infestation and of investments, long-term and short-term investments, because which type of organic fertilizer will a farmer choose? In many cases, that will be liquid manure because it's for free in the Netherlands in the end. And compost is relatively expensive. Well, I just told you that you will earn back the compost. But for farmers on the short term, this will be a dilemma. Another example would be what to do with the straw after you cultivated cereals. You can sell it for a good price, the straw. You have the cash right in your hand. Or you could incorporate it into the soil and then hope that in the long term it will benefit you. Well, in the long term, answer B will be the best answer. And luckily, many farmers, increasing amount of farmers, number of farmers will choose for option B. Well, actually, this is my last slide, and this is a citation from a farmer who said, well, yes, he realized that his soil was as important as his wife, actually. So, of course, I don't know how he treats his wife, but I thought it was a nice citation. So this is the end of my presentation, and thank you for your attention, and hopefully you will have some interesting questions for the discussion.